Hello everyone, in this class we are going to start the algorithm with recursive approach. So let's start. So first thing is recursive approach of algorithm. So first thing is, what is recursion? What is recursion? Recursion means a function called itself. Such a function is called recursive function. Now, if any algorithm, if we use a function which called itself, is called a recursive algorithm. Clear? Now, how to find the time complexity How to find the time complexity of an algorithm that has recursive implementation. How to find that thing? How to find the time complexity of that particular algorithm that used a recursive implementation? So, to find the time complexity of such an algorithm, first we need to find the recursive equation for time of that particular algorithm. That means, first what we need to do? First we need to find the recursive equation for time taken by the algorithm. So first step is to find the recursive equation. For time taken by the algorithm. Clear? After finding the recursive equation, we can use this recursive equation to find the time complexity of this particular type of algorithm. So next step is use recursive equation to find the time complexity. Clear? And by using the recursive equation to find the time complexity, we can use two different methods. First one is called back substitute method. And the second one is called tree method. Clear? Look, after finding the recursive equation, we can use any of these two approaches to find the time complexity. We are going to learn both of these two approaches. Whatever you get familiar or easy or comfortable with, you can use that particular method, but I will refer both of these two approaches to learn. Clear? So first step, what we need? First we need to convert the given algorithm. So we have recursive algorithm, and from this recursive algorithm we need to find the recursive equation. recursive equation for time. And after finding this recursive equation, we can use two methods. First one is back substitute method. First one is called back substitute method. Back substitute method, and second method is called tree method. Clear? So by using back substitute method and tree method on the recursive equation, we can find the time complexity of recursive algorithm. This is the whole approach. So first we need to know how we can convert any given recursive equation into its equivalent recursive equation of time. Clear? So first we need to learn how we can convert a given recursive algorithm into its equivalent recursive equation for time. Clear? So let's do it. After that, after we get to know how we can convert any recursive algorithm to recursive equation, and then we learn how we can apply back substitute method and tree method to find the time complexity by using this recursive equation. So first thing first, let's go with recursive equation. How to form recursive equation? How to form recursive equation? Recursive equation, but this recursive equation we will form with respect to time only, time taken by the algorithm. Clear? Now let's say a given algorithm is like that. Again we have a function, and within this function we have some termination condition. Like if n greater than 1, and then we call the function, let's say this function is taking the argument n. If n greater than n, then we call the function n minus 1 again. Now how to find the time this is our recursive algorithm. Why this is called a recursive algorithm? Because this is a function, and this is our function body, and within this function body we are again calling the function, we are calling the same function. From here we are calling again the same function. That's why this one is a recursive algorithm or recursive program. So how to find the recursive equation for time taken by this particular algorithm? Now look at here. What is this n? N means number of input. What is this n? N defines number of input. So let total time taken by the function when the number of input is n is t of n. That means time taken by function when number of input is n. Clear? That means this is our t of n. That means this function, the time taken by this function is t of n, because this is our n, that means number of input. Now how many time taken by this particular statement? Look here, what system will do? System will just check whether this particular statement is true or not. System will check this particular statement is true or not. Clear? So whenever we have any statement, any instruction that is neither loop nor a recursive call, at that time we know that that particular instruction will take only constant time. That means this particular instruction will take only constant time. Clear? And what will be the time taken by this particular function? Now look at here, the number of input in this particular function call is n minus 1. So the time taken by this particular function will be t of n minus 1. Why? Because we consider that t is the time taken by the function fun when the number of input is n, is this. Now if the number of input is n minus 1, when how many time it will take? It will take t of n minus 1 time. Clear? Now when this particular instruction will execute, this particular instruction will execute only when the number n is greater than 1. Clear? And what happens when the number is equal to 1? At that time it will execute only this particular statement but never enter inside the loop, inside the if block, Why? Because when the number of input n is 1, at that time 1 greater than 1, that means this condition becomes false, and because of that this instruction will not going to execute. Clear? So this instruction will execute only when n greater than 1, and when n equal to 1, at that time this particular statement only execute. That means this particular statement will execute for all the case when n greater than equals to 1. Clear? And if n equal to 1, at that time this part will not execute, and for all other case when n is greater than 1, at that time this whole part will execute. Hope you understood the concept. So let's find the recursive equation with respect to this particular recursive function. So the time taken by this function is t of n. Now t of n equal to, we have two cases. When n is greater than 1, at that time how long it will take? That means how many time it will take? At that time this algorithm will take t of n minus 1 time plus c. Why this c? This c is because of this condition checking purpose. And this thing is happened only when the number of input is greater than n. That means this will happen only when the number of input is greater than 1. And what happen when the number of input is 1? That means when n equal to 1, at that time what happen? At that time this part will not execute, only the if part will execute, and to execute the if part only a constant time is required. That means at that time we have the function will take only a constant time. This is how we can convert any recursive function into recursive equation for time. Recursive equation with respect to time taken by the algorithm. And we know the time taken by any algorithm depends on the number of input. Clear? The time taken by any algorithm is depend on the number of input. So the time taken by the function when the number of input is n is t of n. So when the number of input will become n minus 1, at that time the time taken by the function will be t of n minus 1, and this function will execute only when this condition becomes true. And when this condition becomes true only when the value of n is greater than 1. If the value of n is 1, at that time this function will not execute, only this if part will execute and terminate the execution. Clear? So to execute this part, we need only constant time. That is what this scenario, that is what in this case it is defined. And when the number of input is greater than 1, at that time first it executes this if part, because of what we get this constant c, and after that it will again call the function with number of input is n minus 1, and for this we need time t of n minus 1. Now look at here, this time function is again, this time equation is again a recursive equation. This time equation is again a recursive equation. How? Because this is the function t, again we have the function t. That means within this function definition, within this time function definition, again we have the time function definition. That's why the recursive equation again becomes a recursive function. Clear? Hope you understood the concept, how we can convert any particular given recursive algorithm into its equivalent recursive function. So let's do it with one more example. Let's say we have function n, where first we are doing one loop for n, for I equal to 1 to n, we are printing a, b, c, and then if n greater than 1, at that time we are calling this function fun by n by 2. Now what happened in this scenario? Now again, first thing first, the time function is t, and here the number of input is n. So what will be the total time taken by this function is t of n. Now here is the main scenario. How long it will take? Look, this loop is execute for 1 to n. That means, and each time it will take only a constant time. That means how long it will take? It will take only order of n time. Clear? Because this one is a iterative process, and in this iterative process we know how to find the time complexity, so we will get order of n. And the next, what happened for this if condition? For if condition it will take only a constant time. Now this function, again we are calling the function, and for this function what is the time taken? The time taken by this function we define by another time function, that is t. So now here in this case, this function, what is the number of argument? That is n by 2. What is the number of input? That is n by 2. So the time taken will be n by 2 again. So how to make the recursive equation? That is t of n is our total time for n number of input. Now look at here, what happens when the number of input is 1? Now if the number of input is 1, at that time this loop will execute only for once. At that time this loop will execute for only for, the whole loop will execute only for once. That means at that time it will take only order of one time when n equal to 1. And here this also take only a constant time. That means again order of 1 we will get. That means the both case gives us only a constant time. Clear? This is when the number of input is 1, when the value of n is 1, because here we start from 1 and end in n, and the n is 1, so this loop will execute only for once. Clear? And whenever it executes only for once, 1 into c, that means we will get a constant time only, and that constant time we can represent by order of 1, that we already know. Now again, when the number of input is 1, at that time the n greater than 1, this condition becomes false. That means this function call will not execute, so it will take only this much time. That means only a constant time, and again a constant time is represented as order of 1, so both are constant, so both together again constant, so we can simply represent the whole constant time as c. That means the time taken by the algorithm will be c when the number of input is 1. Now what happened when the number of input is not 1, it is greater than 1. Now when the number of input is greater than 1, at that time the whole thing takes order of 1 time, and this if instruction takes constant time, that means we will get order of 1. Clear? So among these two things, which one is larger? Order of n is the larger term. So we can define as order of n plus. This plus comes for this particular function. Then how long it will take? It will take t of n minus 2 time. That means order of n plus t of n minus 2 time. Now when this thing true, this thing comes when the number of input becomes greater than 1. When the number of input becomes greater than 1. This is the equivalent recursive equation for time taken by this particular recursive algorithm. Clear? Now we can simplify this particular function as t of n equal to, this one is simply c when n equal to 1, but this thing we can simplify. Order of n we can directly represent it as n only, n plus t of n by 2 times and n greater than equal to 1. What does it mean? What does it mean? Now look at here in the algorithm. Now in each step the number of, we call the same function, but in each step we are calling the same function, but the number of input is half. Number of input becomes half of the previous number of input. Clear? Now look at here. If in initial case that value of n is 10, in this case the value of n becomes n by 2, that means 5. Clear? So, and before this function call, along with this function call, we need to do some other task. These are the some other tasks, and to do this task, whenever the number of input is greater than n, at that time how long it will take? It will take order of n time in total, because for this loop we need order of n time, and for this particular statement it needs order of 1 time. But among these two, which one is dominating term? And the dominating term is order of n. So we consider only order of n, and we can ignore this order of 1 term. Clear? So that is how we can convert any given algorithm into its equivalent recursive equation with respect to time. Clear? Let's take one more example and say what happened. Let's say function n is the number of input, then if n greater than 1, at that time we will call this function fun n by 2 plus fun n by 2. What happened? Now what happened? Now again same thing. The time function for this function will be order of n, t of n. The time taken for this particular instruction is c only. The time taken by this function is t of n by 2. The time taken for this function will be t of n by 2 only. Now when these two things come into picture, whenever the number of input is greater than 1, that means this thing come into picture whenever the number of input is greater than 1, and when the number of input is greater than equal to 1, at that time this constant time will take. This thing will take whenever n greater than equal to 1, because whenever n is 1, at that time also this particular instruction will execute, and based on the result, because this result will becomes false at the time when n is 1, because n1 greater than equal to 1, that is false, so this statement will not execute, so this 2 time function will not come into the picture at that time. Clear? So now we can simply convert this algorithm into recursive equation. So what we will get? We will get T of n equal to, when n equal to 1, we just need to execute this particular function if statement. So we need only constant time when n equal to 1, and when n greater than or equal to 1, at that time also this part will execute. Along with this part, these two part also come into the picture. So c plus t of n by 2 plus t of n by 2, this is the total time taken by the function when the number of input is greater than 1. Clear? Now we can simplify this equation like that. T of n will be constant when n equal to 1 and constant plus 2 t of n by 2 when n greater than 1. So this is our recursive equation equivalent to this particular function. Now look at here. What is this? What does it define? It defines with some constant work, we can divide the particular given problem into two sub problem. This is 2. These two define two sub problem where the number of input becomes half. Look at here. With this task we can divide this particular problem into two sub problem, and both of these two sub problem have number of input as half of this particular number of input. With this particular task, with this constant task, we can divide the given problem into two sub problem with number of input is half. Clear? This is the meaning of this particular algorithmic approach, and this is the equivalent recursive function that represent the time required to solve this particular recursive algorithm. Clear? So hope you understood how we can convert any particular given algorithm, recursive algorithm, into its equivalent recursive equation for time taken by the algorithm with respect to time. That means how long it will take to execute any particular algorithm with recursive approach. That thing is defined by using this particular recursive equation. So in next class we will learn how we can use this back substitute method and tree method to find the time complexity by using this recursive equation, by using a given recursive equation or by using a given algorithm. If recursive equation is directly given, at that time we can directly apply any of these two approach to find the time complexity. But if the recursive equation is not given, first we need to find the recursive equation from the given algorithm. First we need to find the recursive equation. After that we can use any of these two approach to find the time complexity. So that's it for this class. Thank you. See you soon in our next class.